Hi, I always thought the reason we do water changes is to manage the nitrate build-up, because pretty much every book you read on the subject of maturing a pond or aquarium tells you this. But actually I'm not sure that is the reason. So I've set out an experiment to work out what's the bigger problem, nitrate build-up or carbonate depletion in a koi pond. So let's start by looking at the nitrogen cycle, which is somewhat incomplete. And I'll explore some of the additional elements that we need to consider when we're considering what affects the amount of nitrate that builds up in a pond. So let's start from the beginning. We put food into the pond, which the fish eat, and they convert it into ammonia. This then gets converted by the nitrosomonas bacteria into nitrite, which gets converted into nitrate. And this is what people usually think of as the nitrogen cycle. But there's a bit more to it than this. The fish produce solid waste, which drops to the bottom of the pond. They also grow. So some of that nitrogen actually goes into the body of the fish. Also, some of the bacteria that convert the ammonia grow and they incorporate some of the nitrogen into their bodies as well. Same for the nitrobacters. You have gassing off, where bubbles and agitation of the water result in ammonia leaving the water and going into the air, and you also have anaerobic bacteria turning nitrate into nitrogen. And you have plants and algae that use the nitrate for their growth. So actually we're building up quite a complex picture here, and in addition to all this, the bacteria use carbonate in the water as part of this overall process. So we're using up carbonate and we're producing nitrate, but the nitrate is getting used in lots of other places within the pond. So what we're going to investigate is what causes a bigger problem. Is it the nitrate building up that causes a problem ultimately for the fish, or is it the depletion of the carbonate, which would lead to fluctuations in the pH and also the bacteria not being able to do their job properly? So let's get into the experiment. What we've got here is we've got 3 tanks with 5 litres of dechlorinated tap water in. They're all heated to 20 degrees. And I've got some mature K3 in there, plenty, and it's got the aeration, the air stone. And I'm going to add 5 milligrams per litre of ammonia and let the bacteria get to work, and then I'm going to test the water and see how much carbonate has been used up, and also look at how much nitrate has been produced. And so what's the difference going to be between these 3? Well, this one, I'm just going to leave it as it is and just continue adding the ammonia and see how much nitrate develops over time, and also measure the carbonate hardness going down. This one here, I'm going to do 10% water changes. For every time I add 5 milligrams of ammonia per litre, I'm going to do a 10% water change before I add the ammonia. Which will simulate what it's like doing your weekly water change with your pond. And then this one here, I'm not going to do any water changes, but I'm going to add a carbonate buffer, so that's this stuff, to keep the carbonate up. Now, in a previous video I looked at using oyster shells, crushed oyster shells, which is something that's recommended for maintaining hardness. I'm not actually that convinced that they do very much. They don't dissolve very well, and in my experiment they didn't really keep the carbonate hardness up to a level that's satisfactory. I've used this in some of my other experiments that I haven't videoed, and this works really well. It dissolves very quickly and it really does boost the carbonate, so that's what we're going to use for this experiment. Now, the test kits, I'm going to check my ammonia to check that's all been used up, and nitrite with these API kits. These are really good because you get plenty of tests within the kit, and I also use a smaller amount, so I only use fewer drops, and it still gives me a good test, but it means that the bottles go further. I'm also going to do this nitrate test. Now, my experience of those is that they involve a bit more effort because you have to shake it for a certain length of time after you've put in both of the reagents. So we'll see how we get on with that. And then this one, I'm going to test the carbonate hardness using this API test as well. I've landed on using API because the bottles are much better value for money than some of the other test kits. You get a lot of tests out of them, and I'll be using that to measure the results. Okay, well, it's results time, and this has been a fairly unusual set of results because I was expecting the nitrate for all 3 samples to gradually build over time, and whilst we've seen some gradual build up, we've also seen it decline in the last 2 samples that I've tested as I've added more ammonia. Now, I know that all of the ammonia is getting changed to nitrite because I've been testing for ammonia, and I know the nitrite has been converted to nitrate because I've been testing for nitrite as we go through as well. So somewhere this nitrate is disappearing, which is slightly surprising given that the media we're using here is plastic media, not renowned for having anaerobic bacteria. Maybe there's something going on in the air stones. I don't know if that's a place where you can get anaerobic activity, but something that I'm a little bit surprised about, but we saw across all 3 samples, so there's something consistent going on. A point to mention actually is that the nitrate tests seem to be quite variable. You certainly need to shake them vigorously to make them work properly, and I think that reliance on being shaken vigorously, although I did all 3 at the same time in the same hand, so that, you know, each one had the same, it's difficult to make that consistent across the days, which might explain some of the variation of the colours between the days. But that's the results on nitrate. On the carbonate hardness, we see without water changes it gradually reduces over time. A little bit of statistical noise there in terms of the numbers, but a very clear pattern of reducing to really unacceptable levels by the end. 2 degrees in one of my other experiments about carbonate hardness, I found bacteria starting to be compromised. They're not working as efficiently, and indeed when I tested the ammonia of this is 1, 2 and 3, that is a slightly different colour from the other 2, and it was slightly green. The colours faded because that was a few days ago now that I did that test, but they weren't working as efficiently for 1 as they were for 2 and 3, so that reinforces the message from my previous experiment. Now, if we have a look at the 10% water change, that reduces as well, but that does so at a slower rate, so we've got a question as to whether the water changes are big enough here and what level that would plateau out. And then we've got the 3rd one where we're adding a carbonate buffer. I add that in on the 4th day here, and that boosts it up to 20 degrees and it stays there for the remainder of the experiment. So carbonate's certainly not a constraint within that one. The buffer worked extremely well. So in the experiment it was controlled conditions, we didn't have any plants or algae, so here my nature pond, you can see there's lots of algae and plants. That's because of the tadpoles. I leave the hair algae until the tadpoles are good turned into frogs, but with that removing nitrate from the system as well, it's clear that the main problem with maintaining water quality is keeping the carbonate hardness high enough, and that's if you're not using a buffer, that's the primary benefit of doing water changes, along with removing all that solid waste and getting it out of the system. So carbonate hardness is the reason we need to do water changes for our fish. If you've got a very heavily stocked pond, mine I'd consider to be heavily stocked, you really should consider using a carbonate buffer in order to make sure you're maintaining the carbonate hardness at sufficient levels to keep the fish happy. But if you're doing that, you need to make sure you're testing very regularly to make sure the nitrate is also under control. Whereas if you're just using the natural approach of using sufficient water changes to maintain the carbonate hardness, nitrate will stay in check, just by the nature of it being a lesser issue than maintaining the carbonate hardness. That's it for now. See you on the next video.